Welcome to sequences. So quick definition. A sequence is a function A of n whose domain is the natural numbers so quick review, natural numbers would be 1, 2, 3, etc. Sometimes we also do the whole numbers instead. So the natural numbers or the whole numbers. So the whole numbers, we just start at 0 instead of 1. We typically write the A of 1, A of 2, A of 3 are called the terms. So A of 1, A of 2, A of 3, etc. are called the terms of the series. Sorry, the terms of the sequence. And they're most commonly written just with a subscript. A sub 1, A sub 2, A sub 3, etc. And then if we put in squiggly brackets, A sub n, this means the entire sequence. So just a little vocabulary to get used to. So we have a sequence, which is essentially a list of numbers, but they come from a function. Or they are a function. And it's usually written just with subscripts A1, A2, A3, and then AN in squiggly brackets represents the entire sequence. So for example, let's list the first 5 terms of the sequence. A sub n is equal to -1 to the n plus 1 times 2 to the n over n factorial. So how we read this, A sub 1, presumably they're starting with 1 here, is going to be -1 to the 1 plus 1 times 2 to the 1 over 1 factorial. Or this is just 1 times 2 over 1, better known as 2. A sub 2, we would be looking at -1 to the 2 plus 1 times 2 squared over 2 factorial. So this would be -1 times 4 over 2, otherwise known as -2. A sub 3, we would be looking at -1 to the 3 plus 1 times 2 cubed over 3 factorial, otherwise known as 1 times 8 over 6, or 4/3. A sub 4, you would have -1 to the 4 plus 1 times 2 to the 4 over 4 factorial. This is -1 times 16 over 24, or a -2/3. A sub 5, we would have -1 to the 5 plus 1 times 2 to the 5th over 5 factorial, or 1 times 32 over 120. Which is 4 over 15, I believe. So our sequence, our first 5 terms would be, we had 2, -2, 4/3, -2/3, and 4/15. And then it goes from there. I probably should have specified this first row. Essentially, we're setting n equal to 1, and n equals 2, n equals 3, n equals 4, and n equals 5. Let's do one more example of just sort of notation this time around. We're given the first 5 terms of the sequence. Our job is to find the formula. So there are some common formulas we have. So this is n equals 1 in this case corresponds to 3. N equals 2 corresponds to 7. N equals 3 corresponds to 11. N equals 4 corresponds to 15. N equals 5 corresponds to 19. There are some common formulas, as I mentioned. One common thing is to add the same number each time you move on to the next step. Another common thing is to multiply by the same number. So notice if we list our numbers, to go from 3 to 7, we add 4. To go from 7 to 11, we add 4. To go from 11 to 15, we add 4. And to go from 15 to 19, again, we add 4. So essentially we have our a sub 1 is 3. A sub 2 is 3 plus 4. A sub 3 is 3 plus 2 times 4. A sub 4 would be 3 plus 3 times 4. So what we could do is we could put these all together and say a sub n must be equal to 3 plus, we have some number times 4. And notice a sub 2, we have 3 plus 1 times 4. A sub 3, we have 3 plus 2 times 4. So the number we're multiplying by is n minus 1. So you could write a sub n as 3 plus n minus 1 times 4. We could, of course, rewrite this as 4n minus 1. Right, so this is one common trick. Here's another one. Let's go ahead and determine the formula for the sequence that starts with 2, -4, 12, -48, 240. So some things to notice here. We have alternating signs. So as we saw in the first sequence we were working with, alternating signs came from a -1 to the n, or it could come from -1 to the n plus 1. We'll have to pick which one is appropriate. Right. So in this case, since a sub n is a a sub 1 is a positive 2, that means that we should use -1 to the n plus 1 so that the odds land on positive 1. So we have alternating signs. We need a -1 to the n plus 1 times. Then we definitely aren't adding the same thing each time. Essentially, To go from 2 to 4, we multiply by 2 times a -1, right? So we multiply by a -2. To go from -4 to 12, we multiply by a -3. To go from 12 to -48, we multiply by a -4. To go from -48 to 240, we multiply by a -5. Right? So each stage we're multiplying by a larger number. I'm going to just write up top, n equals 1 corresponds to 2, n equals 2 corresponds to -4, n equals 3 corresponds to 12, n equals 4 corresponds to -48, and n equals 5 corresponds to 240. So essentially what we have is we have a sub 1 is 2. A sub 2, actually, I'm going to write the -1 to the out front. So a sub 1 is -1 to the 1 plus 1 times 2. A sub 2, we have -1 to the 2 plus 1 times 2, and then times another 2 to get us to the 4. A sub 3, we would have -1 to the 3 plus 1 times 2 times 2, and then we multiply by 3. So my power on the -1 is going up. That's me multiplying by a negative. And then I'm just using the number we multiplied on and beyond that. If we go for a sub 4, we would have -1 to the 4 plus 1. Then we had what we had before, times 2 times 2 times 3. And then we are going to multiply by that missing 4. So notice a sub 4 is -1 to the 4 plus 1 times 2 times 4 factorial. A sub 3, we have -1 to the 3 plus 1 times 2 times 3 factorial. A sub 2, we have -1 to the 2 plus 1 times 2 times 2 factorial. And a sub 1 is -1 to the 1 plus 1 times 2 times 0 factorial. Sorry, times 1 factorial. So what we get then is we could take a sub n to be -1 to the n plus 1 times 2 times n factorial. So this is another type of formula we can come up with. Here we're not multiplying by the same number every time, we're multiplying by a slightly larger number each time, then factorials come into play. So this is one way you can go about trying to figure out the formula for a sequence. So this is just kind of very basics, what a sequence is, how the formula and the sequence work together.